Okay, we'll continue the class. So we are discussing trigonometry exercise 8.3 question number 6. Given square root of 1 plus sin a divided by 1 minus sin a, which we have to prove it as secant a plus tan a. So take LHS separately. So LHS is equal to, we can take it as square root of 1 plus sin a in denominator 1 minus sin a. Okay, so I'm doing the rationalizing for the denominator, which is having 1 minus sin a. It will becomes 1 plus sin a is divided by 1 plus sin a. Okay, then in numerator identify, it is having like 1 plus sin a into 1 plus sin a, which can be written as 1 plus sin a whole square. In denominator, it is look like a minus b into a plus b, so I can write as a square minus b square. B square means sin square. Still both are having square root. Okay, and further split the square root for the numerator and denominator separately, so we'll get 1 plus sin a whole square. In denominator, 1 minus sin square a, I can write as cos square a. So cos square a in square root to cancel, here also square root cancel. So therefore we can have 1 plus sin a in the numerator, denominator is cos a. Divide cos a for each and every term, so 1 by cos a plus sin a by cos a. Okay, then 1 by cos a means I can write as secant a. So sin a by cos a we can write as tan a. So just observe RH is what to prove. So therefore we need to prove it as secant a plus tan a. So what we got? Secant a plus tan a, which is what RH is. So therefore it was proved. Next, sin theta minus 2 sin cube theta is divided by 2 cos cube theta minus cos theta, which is equal to tan theta. This is we need to prove it. Okay, so then now, so we can say that LHS is considered directly and take sin theta in common in numerator. Sin theta is taken 1 minus 2 sin square theta. In denominator, cos theta taken as LC, cos theta taken as common. So then 2 cos square theta minus 1. By observation, sin theta by cos theta together we can write as tan theta is multiplied to 1 minus 2 into sin square theta. That alone simplified as 1 minus cos square theta. Okay, in denominator, so don't simplify anything, write as usually. So 2 cos square theta minus 1. Okay, this will further written as the tan theta is multiplied to 1 minus 2 multiply inside 2 into 1 2 and minus into minus plus 2 into cos square theta. In denominator, 2 into cos square theta minus 1. Okay, and in numerator, so tan theta is multiplied to, so 2 cos square theta is a positive, so writing outside first 2 cos square theta and plus 1 minus 2, which gives minus 1. So in denominator, again 2 cos square theta minus 1. By observation, numerator and denominator both are looking same, so we cancel it. So therefore what we get? Tan theta. So this is what RH is required. Therefore LH is equal to RHS. Got it? So further move for the next question number 8. It is given as sin a plus cosecant a whole square, cos a plus secant a whole square, which we have to prove it as 7 plus tan square a plus cot square a. Okay, so we'll try to prove. Take LHS separately and expand in the form of a plus b whole square. Here also a plus b whole square. By expanding, we'll get as sin square a plus cosecant square a plus 2 into sin a is multiplied to cosecant a. In this term expansion, we'll get it as cos square a plus secant square a plus 2 into cos a is multiplied to secant a. So which is I consider LHS. Okay, so we have a relation. Sin and cosecant are reciprocals, both cancel. Cos and secant are reciprocals, both cancel. So from this, here 2 together added 4. 4 plus, here sin square plus cos square as an identity, so writing together sin square a plus cos square a plus cosecant square a and secant square a, so write it as cosecant square a plus secant square a. Okay, Here 4 and this both addition is 1. It's an identity. So writing as 4 plus 1 plus cot square a plus 1 plus secant in terms of tan. So 1 plus tan square a or tan square a plus 1. So by addition all together, here 4, here 1, 5, 5 plus 1, 6, 6 plus 1, 7. So therefore 7 plus, here it is having cot square a plus here we have tan square a. So therefore this is what required RHS. Therefore LH is equal to RHS. So 7 plus tan square a plus cot square a. Here also 7 plus tan square a plus cot square a. So let us move for the next question. Question number 9. Given cosecant a minus sin a is multiplied to secant a minus cos a, which is equal to 1 by tan a plus cot a. So we need to take LHS first. I'll take LHS first. So which is cosecant a minus sin a. Cosecant a we write as 1 by sin a minus sin a is multiplied to secant we write it as 1 by cos a minus cos a. Okay. Here takes sin a is LCM, sin a 1 minus here it is 1, so multiply. I'll get in numerator sin square a and is multiplied to in this term cos a is LCM, here denominator 1, so that multiply 1 minus, so cos a into cos a cos square a. Got it. So now 1 minus sin square a we can write it as cos square a, denominator sin a, multiply to 1 minus cos square we can write as sin square a, in denominators cos a. Any cancellation? Definitely. The square and sin a cancel, this square cos a cancel. So what is still pending? Cos a is multiplied to sin a. So let us imagine it's equation number 1. Take RHS separately. So by taking RHS separately, RHS is equal to 1 divided by tan a. Tan a writing as sin a is divided by cos a plus cot a we write it as cos a is divided by sin a. Got it. So now LCM you take it as, so denominator LCM will be sin a into cos a, sin a into cos a. Here cos a cancel, sin a multiplied to sin a, so it will become sin square a plus sin a cancel, so cos a into cos a will give cos square a. Numerator is 1, and this can be further written as 1 by sin square a plus cos square a is a 1, an identity is divided by sin a is multiplied to cos a. Numerator denominator, again numerator denominators are there, so it can be written as reciprocals. So 1 is multiplied to cos a is multiplied to sin a is divided by 1. So 1 and 1 anyhow same only, so we can write it as sin a is multiplied to cos a. Let us imagine equation number 2. Identify equation 1 and 2 clearly. So cos a into sin a, sin a into cos a, product in anyhow same only. The LHS is equal to RHS, so hence the given requirement is proved. Okay, this is proved. Next question number 10. Question number 10 is given 1 plus tan square a is divided by 1 plus cot square a, which is equal to 1 minus tan a divided by 1 minus cot a whole square, and we require to prove tan square a. So let us take the first condition. So first condition I just write it as 1 plus tan square a. I can write it as secant square a. So secant square a is denominator 1 plus cot square a. So we can write as cosecant square a. Okay. So then this secant square a I'll write it as 1 by cos square a. So then 1 by cos square a in denominator, cosecant square a we write it as 1 by sin square a. So numerator denominator, again numerator denominator, write as reciprocals. 1 by cos square a is multiplied to sin square a is divided by 1. In 1 into sin square a, sin square a, in denominator 1 into cos square a, cos square a. Both together I can write it as tan square a. Okay, so we have got it as tan square a for the first condition. Condition number 2. So condition number 2 having as 1 minus tan a. 1 minus tan a we write it as 1 minus tan a, I'll write it as sin a is divided by cos a. Okay, in denominator 1 minus cot a we write it as cos a divided by sin a. So together having square. which can be taken as LCM numerator and denominator separately. So by taking LCM in numerator cos A, by taking it cos A is minus sin A. Got it. In denominator sin A is an LCM, so I will get it as sin A is multiplied minus cos A, both having square. Identify in numerator cos A minus sin A, but denominator is sin A minus cos A, so which can be reciprocal. So by writing cos A minus sin A divided by cos A is multiplied to sin A is divided by, so I'll take negative outside. By taking the negative outside, I'll get it as cos is positive, cos A minus sin A, both having whole square. So I can cancel this cos A minus sin A, cos A minus sin A. Okay. So in numerator we have sin A, denominator is minus cos A. So both having square. So sin A by cos A I can write as tan A, but negative is pending. So minus tan A whole square. So minus 1 whole square means plus 1. So tan A whole square means tan square A. Therefore the requirement is we got it. So all we got it is equal to tan square A. The requirement to prove is got it.